Hello. In this lab, we're going to demonstrate a braking method. We're going to plug brake, or we're going to momentarily put the motor in reverse in order to stop it. And this is the most effective and fastest way to stop a motor if mechanically it can handle the reversing. Not all motors can. If it's not built heavy duty enough, if you try to reverse a motor that's going full speed forward, you might just snap the shaft of the motor back up. This is commonly used in machine tools. Good example is a drill press or a lathe. So if they need to stop that drill press or the lathe extremely fast, they'll reverse it momentarily and it'll come to a complete stop. So first thing I want to look at is the zero speed switch symbols. The zero speed switch, it's a very expensive switch. Still used, but there are less expensive ways to accomplish the same thing. But for machine tools, definitely still used. So one way you might see the zero speed switch symbol is like this. So we've got a common, and we've got a forward terminal and a reverse terminal. And the way this works is when the speed switch is turned in the forward direction, it's going to move up, and we're going to get continuity between these 2 points. And it will stay in that position until it's come to a complete stop. So the idea is when we start the motor in forward, this is going to close. And when we de-energize the motor, it would coast for a while, and this would not open until it actually stopped. But we're going to use it a little bit differently than that. Another way you might see the symbols is, or if you were to look at the wiring terminals of the speed switch, you would see 4 terminals. One normally open contact marked forward, and one normally open contact marked reverse. Well, this is the same thing. I can make them equal by just jumpering these together. So now this point is common. These 2 points are common, and I have the equivalent of that. So we like to draw it like this just for simplicity. So here's our circuit. So we've got a standard forward and reversing starter. Notice we have the overload relay contact here, only one overload for both. And the forward coil is interlocked with the normally closed reversing auxiliary contact, and the reverse coil is interlocked with the normally closed forward contact. So we've got a stop button and a start button, but look closely at the zero speed switch. Remember, when I run it in forward, this is going to close. But also notice when I energize it in forward, this contact opens. So this is going to open before this closes. It's going to be very close in time, but it should happen first. So when we start it in forward, this contact closes, but because this has opened, R cannot energize. Now what we want to do, when I hit the stop button, I want to de-energize the forward contact. Well, what happens when that happens is the contactor drops out, the normally closed contact closes. Just remember, that thing is still spinning forward, so this contact is closed. So what will happen is this is closed. When this closes, this will energize. And it will slam that motor into reverse very quickly. And we'll notice this will only come on for a short period of time, or until the motor stops. As soon as it stops, this is going to open and R is going to de-energize. We've also got what's called a lockout relay. It's a safety relay. So there's a little coil. I'll just call it LOR, lockout relay. And what we're going to do is we're going to connect it to T1 and T2 of the motor. I like to call this the arming relay. And it's a safety relay because what I can do, if I don't have this lockout relay, so it's going to prevent anything happening here, that changing. If it doesn't see power on T1 and T2, and T1 and T2 are going to both be energized, or we're going to get 200 volts across them when I start the motor in forward. Remember, these are just two terminals in the motor circuit itself. So I like to call it the arming relay, because the problem here is if the circuit is dead, and I go to the shaft of that motor and spin it with my hand in the forward direction, well, this contact is going to close. There'll be enough centrifugal force to close this contact. My hand might be on that pulley, it slams into reverse, and next thing you know, I've only got 3 fingers. So it is a safety device that we have to take into consideration. Hello, in this video we're going to demonstrate plugging braking, or momentarily reversing the motor in order to make it come to a complete stop in the fastest way possible. So here we've got a small 3-phase motor, and we've got our 0-speed switch here, and we're coupled together with this belt and these pulleys. On top of the 0-speed switch, we've got the lockout relay, or my safety, or I like to call it the arming relay. And if I try to spin this motor right now, even enough to close the contacts, the motor would not start, because it needs, we've run 2 wires from T1 and T2, or when we energize T1, T2, and T3, we energize this little transformer that feeds this transformer and arms our relay. So unless that is energized, this speed switch will not put the motor into reverse, just for safety reasons. Over here we've got our motor control center, and we have this starter is the reversing starter for this lab, and we've got 2 indicating lights. The green one will indicate when the motor is running in forward, or when the forward contactor is energized. The amber light will indicate when the reverse contactor is energized. So I'm going to use these buttons to start and stop the motor. So here we go. So the motor starts, and I'm going to stop the motor, and you can see how quickly a stop it came to. Let's do that again. And there is no way to stop that motor faster than that. If you have a look at the indicating lights, you'll see when I start the motor in forward, the green light comes on. When I stop the motor, the amber light will come on, but for a very short period of time. So we'll do that again. Now, to review our schematic diagram, I've added the green and the amber pilot light. So again, we have to understand that the 0-speed switch will, when it's turned in the forward direction, it will move this way, and we'll get continuity between the common and the forward terminal. When it's in reverse, it'll go down this way, and we'll have continuity between the common and the reverse terminal. When we start the motor, the forward contactor energizes, the motor starts to spin in the forward direction, it seals in. At the same time this opens, maybe a split second later after this opens, this will close, but R cannot energize because it's running in the forward direction and we have our electrical interlocks. When we hit the stop button, the forward contactor de-energizes. Remember, the motor is still spinning in forward, so this contact is closed. After the forward contactor drops out, this contact closes again. It goes into reverse, but only for a split second until this opens, and then we de-energize the reverse contactor and the motor will be at a complete stop. What am I missing from this drawing? The only thing I didn't draw is the mechanical interlocks or the mechanical linkage between the forward and the reversing contactor, which is required by code. We must have our electrical interlocks and our mechanical interlocks. Thank you.